I want to approximate this function at, let's say, at 1.002, it may be easier to approximate if I'm not keen on exact answer. If I use the linear function, which is the tangent at that point, I will not encounter a huge error. If I want exact, forget about the tangent, plug it in. But if I'm happy with an approximation, I can use the equation of the tangent line, which is the linear approximation of the function. Now, if you say, what about at this point? I'll say, sorry. For this point, you have to create another function, another linear function, because they're far away. So now this equation of this tangent will approximate the function near B. What about here? Well, that's a different tangent. This line would approximate the function near C. So two concepts, they are basically identical. One is called this, the linearization, and this one is the approximation, the linear approximation of the function near or at A. Okay, so now let's practice this idea. These are the easy problems at the top. But I wanted to talk about the differentials first. Find the linearization. So let's choose. Then find the differential. We can choose, of course. And then evaluate, so on and so forth. And find delta x, delta y, dy, dx. And that's it. So let's start with the linearization. Which problem we want to work on. Okay, let's say 2. So I have f of x equals e to 3x, and a is 0. They want the linearization. So I know the formula. This is f of a plus f prime of a, x minus a. So this is 0. I have to find f of 0. So f of 0 will be e to 0. How much is that?
1.
Perfect. So this is done. This is clear. It's just x. F prime, I have to find f prime of x first, and then plug in 0. Can anyone give us the f prime for e to 3x?
E to 3x times 3.
Very good. And now let's find f prime of 0. You already told me that e to 3x is 1, so 1 times 3 must be 3. So what is the linearization then? F of 0 is 1. F prime of 0 is 3. X minus 0 is x. Done. That's it. Yes. Any questions? So what does this mean? Near A, like 0.01 or negative 0.003, you don't want to evaluate this function if you're not super keen on exact, right? So you will plug this in here. So much easier than plug it in there. You don't know how to do that. But we know how to do this. So this will be for 0.01 near 0. Do not say 3. 3 is not near 0, and you cannot use this line to approximate that function near 0. So, but at 0.01, I have 0.03, so this will be approximately 1.03. You had no idea. Now, if you want to approximate it or find a value at negative 0.003, you have to plug in the calculator. But now it's very easy to do it here. So this will be negative 0.009, and it will be approximately 1 minus 0.009, which is what? 0.991. You had no idea that you can evaluate this at negative 0.0003, and you come up with that. Why were we able to? Because this function can be approximated by this line near 0. Any questions, please? Any questions? Okay, that's the linearization. Let's see, the linear approximation now. Let's, which is exactly the same. So let's look at the differentials. So let's choose from 11 through 18. Please choose. We're not asked to find the derivative. We're asked to find the differential of the function. Can anyone choose a problem? Any function? You said 15?
Yes.
Good. 15 it is. So we have y equals 1 over x squared minus 3x. Good. When I see a number like this at the top in a fraction, I always do this. And I highly recommend it. Now, if you have x, you cannot do that. I mean, I shouldn't say you cannot. You can, but there is no point. But since the numerator is just one constant numerator, I think it's easier to change it into x squared minus 3x to negative 1. Of course, if you have power 2, it will be to negative 2, and so on and so forth. And remember, we are asked to find dy, which has to be f prime of x times dx. So I only have to differentiate negative 1 in front, subtract 1 from the power, times the inner function prime, times dx. If I forget the x, I'm not getting the differential. I'm only getting the derivative. But the problem was clearly stating, find the differential of this function. Yes, I will clean it up a little bit and rearrange it a tiny bit. So then dy equals negative 2x minus 3 over x squared minus 3x, everything squared, dx. It should be written like this. Can you keep it like this? Yes, for now. That's the differential of the given function. Any questions? Any questions? Okay, I'm plugging in my device, is running out of juice. Okay, so do you want to choose another, or we move on to other types of problems here?
Can we do 16 as well?
Of course, 16. Oops. 16. This is not good anymore. So y equals the square root of 1 plus cosine theta. Good. Perfect. Again, dy equals f prime of theta d theta, because this function has the variable theta. The derivative, we know, y prime or f prime of theta is 1 over 2 the square root of 1 plus cosine theta times the inner function prime, negative sine theta. And that's it. So now dy equals this, negative sine theta over 2 the square root of 1 plus cosine theta times, if I forget d theta, this is incorrect, times d theta. Any questions on this? Are we okay with this type of problem, finding the differential? Okay, so I would like to look at the next set of problems, 19 through 22. Find the differential dy. Evaluate dy for the given values of x and dx. And then 23 through 26. Compute delta y, dy, and then sketch the diagram. You don't have to sketch the diagram. We already did sketch the diagram several times. We know that delta y is approximately dy. Okay, so let's start here. Let's choose a problem from here and one from here. Anyone would like to choose? Okay, I will choose, I don't know, 21. We just did a square root. Let's look at 22. Y equals x plus 1, x minus 1, x equals 2, and dx is tiny, 0.05. Okay. So they want us to find the differential first and then evaluate it for something. Okay. So remember the differential will be f prime of x dx. So let's find f prime first. Can anyone tell us what to write at the top? I will write the denominator. Can anyone give us the numerator?
X minus 1
Yes.
times 1
Minus,
minus
in
X
parentheses, x plus 1 is better. So the top prime is 1 times the denominator minus the top times the denominator prime. Awesome. So x minus x, that will go away, negative 1 minus 1. So this is negative 2 over x minus 1 squared. So therefore, I go back up here. Maybe I shouldn't go back. Maybe I should write it on the next page. So then I know that dy equals negative 2 over x minus 1 squared. If I forget the x, this will be incorrect. Now at this point, I can plug those numbers in. And that's it. So then dy equals negative 2. The denominator 2 minus 1 is 1. The dx is 0.05. So this is negative 0.1. Any questions? Too easy, right? Everyone is okay? Is everyone okay?
Yeah, I'm okay.
Okay, thank you. So let's look at, thank you, Gabby. So now let's look at compute delta y, which is the exact, a totally different formula. It's not an approximation. It's always more difficult to determine. More calculations, more work. dy is just f prime of x dx. Very simple. But dy is more work. That's why we want to replace it by dy. When we are happy with a little bit of error. If I'm not happy, if it's human life, I'm not happy with any error. I want this. But if I'm talking about the length of pencils, I'm very happy with this. I know I have a tiny error, but I'm happy with it. Good, so let's choose.
Number 24.
24. Very good. 24, we have y equals x minus x cubed. X is 0. Luckily, delta x is negative 0.3. Very good. So they want delta y dy, and maybe they want us to say, oh yeah, look how close delta y and dy are, and brag about it, and just determine we're given delta x, but delta x is the same with dx. So I can already write it here, same thing with dx. So I'm going to start with the easy one, with dy, which is f prime of x dx. So for f prime of x, no problem. I have 1 minus 3x squared. Cannot be easier, plug it in. So dy equals 1 minus 3x squared dx. And it's done. All I have to do is just plug in the numbers. So dy equals, so x is 0, so this is 0. This is negative 0.3. Negative 0.3 times 1, negative 0.3. That's the easy part. Now, however, if I want the exact, then I have a much bigger situation here. Delta y is f of x plus, let me also write delta, not d, delta x minus f of x. The f of x is not a big deal. 0, 0, nice. But this one, it's 0 minus 0.3, so I have to find f of negative 0.3. You can say not even that is a big deal because it's not a big, that's not a problem with the function. Okay, fine. Minus negative 0.3 cubed. 0 really helped because otherwise I would have had more work to do. Okay, so this is negative 0.3. Negative to the third is negative with minus in front will become positive. And this is 27 and 3 zeros. 1, 2, 7. Right? 0.3 times 0.3. So 3 times 3 is 9, 9 times 3 is 27. But I have to have 3 decimal digits. 1, 2, 3. So now this is negative what? I have 3, and I have 7 and 9. Not 9. 2.
4.273.
Yes, thank you. Thank you so much. So is delta y approximately dy? Yes, it is. Negative 0.273 versus negative 0.3. So this was the approx. Nice and easy to find quickly. And this is the exact. And that's all I had to say for and about this chapter. Now it's up to you what you want. We still have, I'm not sure how many minutes, 6. So what would you like to practice? What would you like to do for the next 6 minutes? Do you need help with anything? From WebAssign or anything that you encountered? So this is the exact, and this is the approximation. Look how easy the approximation was. And here, if this is not 0, then I'm in trouble. I have to whatever. But it was nice because it was 0. But this is so nice and easy. And we use
x is 0 because x is 0, right?
Because they gave us 0.
Okay.
Yes. It just happened. We can work on any other one. So it just happened as x was 0 here and here. We can work on any other if you like.
Can we do a 25?
Yes. So let's do 25. Perfect. Okay. In 25, I have y equals the square root of x minus 2, x equals 3, and delta x, which is dx, equals 0.8. Perfect. So I'll start with the easy step with dy, which is f prime of x dx. I will find f prime is 1 over 2 the square root of x minus 2 times the inner function prime, but it's 1. So then dy equals 1 over 2 the square root of x minus 2. Don't forget dx, please. So then dy is 3 minus 2 is 1, so it's 1/2 times 0.8, so this is 0.4. Now this is the approx, because I used the differential, which is an approximation of the exact. But now they want the exact. Okay, so the delta y is f of x plus delta x minus f of x. Even now, f of x is nice because 3 minus 2 is 1. The square root will be 1. But how do I determine f of x plus delta x? I have to determine f of x plus delta x means 3.8. So this is the square root of 3.8 minus 2 and minus 1. Or the square root of 1.8 minus 1. So I will put this in the graphing calculator. And I have, let me clear all this. The square root of 1.8. And of course outside minus 1. And this has to be close to 0.4. So this is 0.3416. And this is the absolute exact. You can say it's not